This video is brought to you by mywayteaching.com.
Next is consider the problem. PCl5, PCl3 and Cl2 are the equilibrium at 500 Kelvin and having concentration 1.59 mole PCl3 and 1.59 Cl2 and 1.41 mole PCl5. Calculate Kc for the reaction. Kc is nothing but equilibrium constant. Kc for the reaction. Okay, so PCl5 PCl3 plus Cl2. Next, so that is the question. Here the solution is, you know that for the equilibrium constant you have to write the product PCl3 and this is Cl2 divided by PCl5 is equal to, this is the value they have given 1.59 for both same value, so that's square. And what is the PCl5? 1.41. What you are getting? 1.79 Kc value. Okay, next problem. The value of Kc 4.24 at 800 Kelvin for the reaction. I will write carbon monoxide plus H2O, carbon dioxide plus dihydrogen. Calculate the equilibrium concentrations of carbon dioxide, H2, carbon monoxide, water at 800 Kelvin if only carbon monoxide and H2O are present initially at concentration of 0.10 mole each. Okay, I will solve it. Okay, here solution for the reaction. Please note down what I am writing here. For the reaction, carbon monoxide plus water. Okay, so this is carbon dioxide plus H2. Initial concentration 0.1 mole, 0.1 mole, 0, 0. Let x mole per liter of each of the product be formed. Let x, okay, mole per liter of each of the product be formed. Okay, at equilibrium 0.1 minus x, you can write this one as this. Okay, then 0.1 minus x, x molar, not write it down. Okay, next, you know where x is the amount of carbon dioxide and dihydrogen at equilibrium. Hence equilibrium constant can be written as hence Kc can be written as Kc is equal to x square divided by 0.1 minus x square x. So this is 0.1, 2 is there. So 0.1 minus x whole square is equal to 4.24. This can be written as x square 4.24.01 plus x square minus 0.2x. Okay, so that x square is equal to 0.0424 plus 4.24 x square minus 0.848x. So 3.24 x square minus 0.848x plus 0.0424 is equal to 0. On solving this, you are getting a is equal to 3.24 and b is equal to minus 0.848 and c is equal to 0.0424. And okay, for this can be how you got this one. So this is a value, b value and c value. For quadratic equation, we know for quadratic equation we can write what is quadratic equation. It is in the form of ax square plus bx plus c is equal to 0. So x is equal to minus b plus or minus, okay, root of b square minus 4ac divided by 2a. Okay, so after that minus b and all, you know, all the values of a, b and c. So you can write after substituting the values, you know, b value is 0.848. Okay, that is plus or minus b square is 0.848 whole square minus 4. What is a value? 3.24. And what is c value? 0.0424 divided by 2a. What is a? 3.24. After solving that, how much you are getting? That is x is equal to 0.848 plus or minus 0.4118 divided by 6.48. Okay, so x1 you can write like 0.848, so minus 0.848 minus 0.4118. How much you are getting? Divided by 6.48. You will get 0.067. Like then for x2 is equal to 0.848 plus 0.4118, okay, divided by 6.48 is equal to 0.194. So the value 0.194 should be neglected because it will give a concentration of the reactant, which is 0.194 is neglected. Okay, because it will give concentration of the reactant which is more than the initial concentration, hence the equilibrium concentration are neglected. Okay, now hence the equilibrium concentrations are carbon monoxide, X is equal to 0.067 mole into carbon monoxide, and H2O is equal to 0.1 minus 67 is equal to 0.033 mole. Okay, so this is the answer. Next problem is, for the equilibrium, I will write down this 2 plus Cl2, which is in gaseous state. The value of the equilibrium constant Kc is 3.75 into 10 raised to minus 6 at 1069 Kelvin. Calculate the Kp for the reaction at this temperature. Okay, we know that. I will write down the solution here. We know that Kp is equal to Kc into RT, okay, whole raised to delta n. For this one, we know we can write delta n is equal to 2 plus 1 minus 2 is equal to 1, and Kp is equal to 3.75 into 10 raised to minus 6 into 0.0831 into 1069, and Kp is equal to 0.033. This is the answer for this question. Okay, that is minus